Hi, I'm Alex from the Zscaler Customer Success and Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for the implementation of a data protection policy inside Zscaler Internet Access. This is part 5, Example Use Cases for Inline Data Loss Prevention. In this video, I'll walk you through an example of how to build policy according to the principles that we outlined in the previous video. Before we start, it's important to understand that the following dictionary and engine guidelines are general recommendations that are not intended to be directly copied into production environments. They should be treated as hypothetical examples of starting points for creating and tuning custom dictionaries for specific use cases. Internal risk and compliance should be consulted. With that disclaimer out of the way, let's get into our example. Here's our example use case. We have an organization that wants to block credit card number sharing by users that aren't allowed to do so. Let's take a look at how we can build this policy out. First, let's create a dictionary that targets credit card numbers with a median confidence score and an engine that leverages this dictionary and has a minimum count of 0. We'll then leverage this engine to create an initial monitoring policy. This is an allow policy, which means our credit card numbers will not be blocked, but this will generate DLP events for each file containing more than 0 credit card numbers, matching our median confidence dictionary. This will allow us to start investigating our data flows. Let's take a look at the lessons learned from this first step. Here's our initial policy. This is an allow policy that only monitors files where there are more than 0 credit card numbers. It's been applied to all users and all applications. The drawbacks of this policy is that there are a lot of false positives, and of course no blocking is at this stage. Here's an example false positive, where we can see how easy it is for a parcel tracking number to be misunderstood as a credit card number. However, at this stage, the benefits of this policy is that it gives us visibility into credit card data that exists inside the organization. Since we're looking at so many false positives, we're going to want to iterate on this in order to get better data. We'll do this by changing our dictionary so that it leverages keywords and has a confidence score threshold of high. When combined with an engine that requires a higher minimum count to trigger, and a policy that leverages this new DLP engine, this will result in much fewer false positives, since the rule will only trigger when there's high confidence that the data contains credit card numbers and a higher number of credit cards contained inside that file. Let's take a look at what we can learn from the first round of iteration that we performed. First, here's our policy. This is still a monitor policy, but this time it targets any file with 5 or more credit card numbers in it, and it only uses high confidence and keywords to identify those credit card numbers. This still applies to all users and all applications. The drawbacks here is there are of course still some false positives, but also we've now introduced some false negatives. There are files that might contain 4 or fewer credit card numbers that will not be flagged by this policy. Of course, this policy is still not blocking anything at this stage. The benefit here is that there's now been a significant reduction in the number of false positives, so we've eliminated a number of false alerts from the system that would otherwise drown out legitimate DLP violations. Let's iterate again. Here, rather than relying on a single dictionary, let's build 2 dictionaries. Instead of a single dictionary with a medium confidence score threshold, or a single dictionary with a high confidence score threshold that uses keywords, we'll create 2 separate dictionaries, one of each. We'll then create 2 engines, each of which leverages a different dictionary, and 2 policies, each of which leverages a different engine. Here's a look at what our policy looks like now. First, we have a policy 1, that is a monitoring rule for all files containing more than 0 credit card numbers, leveraging our high confidence dictionary that uses keywords and proximity to ensure that only files containing actual credit card numbers are caught. Our second policy is a monitor policy and leverages our medium confidence engine, but this time only if there are 25 or more credit cards inside a file. Here, the drawbacks is it will still have minor false positives, as these can never be fully eliminated, and of course, we're still not blocking. But the benefits are that our alerts are now very likely to be genuine. Because of the high confidence, proximity, and keyword requirements for policy 1, it will only trigger on files that genuinely contain credit card numbers. Meanwhile, policy 2 will make sure that we reduce the number of false negatives by ensuring that files with a high count of credit card numbers with medium confidence are still caught by this monitoring policy. Now we need to start building a block policy, so let's iterate again. We'll create a new engine, this time combining high confidence and a higher count. We'll use a combination of high confidence score, keywords, and proximity, but make sure that our count is set to greater than 4. This block policy will then be placed above our monitoring policy. So the first policy in the list will now be a policy that blocks files containing credit card numbers when 5 or more credit card numbers are detected inside the file, using high confidence, keywords, and proximity to guarantee that these detections are accurate. Here, note that we've also restricted the block policy to make sure it only targets file types where data loss is likely to happen. This is PDF and Office files. Let's take a look at what we've achieved with our third round of iterations. Here, our policy now blocks files containing more than 4 credit card numbers using a combination of a high confidence score, keywords, and proximity to ensure that these detections are accurate. This targets all users in all applications, but only Office and PDF files where that data is likely to be. Policies 2 and 3 are the monitoring policies that we've configured before, making sure that we still detect files containing credit card numbers in any number greater than 0. Here, the drawbacks are as follows. First, it's important to understand that false positives are still possible and always will be. Secondly, it's entirely possible that this policy as configured will block some legitimate user workflows. For example, if a user in the finance group wishes to upload a list of credit card numbers to our corporate OneDrive, that will be blocked by the policy. Finally, since our block policy only triggers for files with 5 or more credit card numbers, there's still no blocking for files that have low counts with low confidence. The benefits of this policy, however, is that we now have a block policy in place that triggers on files that contain credit card numbers with a high degree of certitude. Let's iterate on this even further. Since our user workflows were disrupted by our block policy, we'll now configure exemptions. So here, let's say that users in our sales department should be allowed to share files via OneDrive that contain credit card numbers. We'll create an allow rule that targets the sales department and the OneDrive cloud application, and place this rule at the top of our list. This now means that if a user is in the sales department and is sending a file containing credit card numbers to OneDrive, then that action will be allowed since it matches our exemption rule. Our policy now looks something like this. At the top of our policy list, we have a policy that says that people in specific groups can upload files containing credit card numbers to the corporate instance of OneDrive. Our second policy will block files containing more than 4 credit card numbers. Both of these will leverage keywords, proximity, and confidence score to make sure that these blocks are true. And then our third and fourth policies remain the monitoring policies that we configured before. Our drawbacks are still that it's possible for some false positives to happen, and that we're not blocking low counts with low confidence. On the other hand, our policy now blocks files that contain credit card numbers with a high degree of certitude, and user workflows are no longer negatively impacted. We can still iterate on this, but these are only the first few steps in a process of continuous iteration. If you follow this process repeatedly, continuing to build a complex policy, you might end up with a policy like this. It combines multiple sensitive data types and multiple users that work with that data. Here on the left, we have our credit card policy we just talked about, with policy 1 allowing people in the sales groups to upload credit card numbers to the corporate instance of OneDrive, and then policy 2 blocking files containing more than 4 credit card numbers with high confidence. Policies 3 and 4 are our monitoring policies for credit card data. Policy 5 is then an exemption policy that allows people in HR groups to upload P2I to their corporate instance of Workday. Policy 6 mirrors our credit card number policy by blocking the upload of files containing more than 4 counts of P2I using keywords, proximity, and a confidence score to guarantee detection. Policy 7 and 8 mirror the monitoring policies for the credit card, allowing us to continue gathering information about DLP violations even when they're not blocked. To conclude this video, let's take a look at a few other data type use cases. I won't go into nearly as much detail as I did for credit card numbers, I'll just give a few highlights. The first one of these is date of birth. This is frequently used with P2I data, and in combination with other sensitive data can itself be considered P2I. Here, the suggested match type is to match any patterns in any phrases, and have proximity configured. Examples of high confidence phrases that you could leverage for your dictionaries here are date of birth, year of birth, month of birth, etc. And you would also want to build regex patterns that match the common formats for dates of birth. A suggested DLP engine here would seek to match counts for both the pattern and the phrase at the same time. Finally, here's an example for source code. For Java, the predefined source code dictionary is not language specific, does not trigger for detected content under 1 kilobyte, and checks for terms and syntax used by most coding languages. Here you would want to target your policy to specific file types, i.e. source code files, and to departments or user groups that might try to share source code files. You'll want to focus on patterns that must be in the code for it to be valid, and specifically, focus on patterns that are unique to Java and consider similarities between languages. You would therefore want to build multiple dictionaries, one that looks for phrases specific to Java as a language, one that looks for methods, and one that looks for class patterns. A suggested DLP engine here would look for a count of Java class pattern matches and Java main method matches, or Java phrases. That's it for this video. Thank you for watching.